Welcome to video 22 in series 3, and in this video I'll show you how to implement AI that detects the player and then chases them. Okay, so in the previous video I had set up an evil cube that has a nav mesh agent, but it doesn't chase the player. So what I'm going to do is to add a script to the AI that first of all casts an overlap sphere to detect the player. It'll check for the player's lair, and if it detects the player, then it'll set a destination for this nav mesh agent, and by so doing it will chase after the player. So I'll need a new script first of all, and I'll call that say enemy chase, probably detect and chase. But anyway, I'll open it up, and then as usual I'll do my stuff. Okay, and of course namespace, very important, chapter 1. Okay, and I'm going to need quite a few variables. First, a couple for more efficiency, so private transform, my transform, private nav mesh agent, my nav mesh agent, and then I'm going to cast the overlap sphere at intervals, but first of all I need private collider, an array for what the overlap sphere will detect. Hit colliders, I'll call that, just like before. And then a private float check rate. I'll set this in another function. Oops. Private float next check. And then I will also have a public, maybe I'll just put this to the top, public layer mask, player layer. I could call it maybe detection layer is more appropriate. In fact, I do think that is more appropriate. Detection layer, and another one, private float detection radius. So how far is the AI's detection? How far can it detect? All right. So then void set initial references. I haven't spelled that correctly. It's better, I think. Anyway, keep going. And then my transform is equal to transform. My nav mesh agent is get component nav mesh agent. All right. And then the check rate, I'm going to set it as check rate, because see, if I have many AIs all in the scene and they were all spawned at the same time, if they all had, say for example, a check rate of 1 second, then every second all of them will perform the same overlap sphere check, which can be a bit expensive. So I don't want that to happen. So what I'll do is I'll just put a random range of like 0.8 to 1.2 seconds, and so each of the AIs will have a slightly different check time. So by doing that, the load is distributed over a portion of time, and there won't be like a sudden performance spike every 1 second. Alright, so check rate is equal to random.range, not random range, pick range, because random range is obsolete, or going to be, and 0.8f to 1.2f. Okay, right. Next, I'll do a check if player in range. Maybe I'll make another function like that. Check if player in range. Okay, and first of all, my check if time.time is greater than next check. Then in that case, next check is equal to time.time plus check rate. No, nothing new here. Not only that, I also have to do another check. I have to make sure the nav mesh agent is in fact enabled, and my nav mesh agent dot enabled is true. Don't forget the double equal sign. 1 equal is assignment, 2 is comparing. Alright, so then with that done, I need to cast an overlap sphere. So I'll say hit colliders is physics dot overlap sphere, and then where's the position? My transform position. So starting from the enemy's position, what's the radius? Detection radius. Okay, The layer is going to be the detection layer, and That's it. Okay. Alright, so then I do another check. If hit colliders dot length is greater than 0, so if there's actually something in there, then that means we've got our player. We've detected the player. So in that case then, we give our AI a destination. So we say my nav mesh agent. So my nav mesh agent dot set destination. Where should that be? Oh, well, it should be what was detected. So the hit colliders, the first entry in it, which is the player, which has been detected because there's only one player in the scene, and so of course only one item will be in that array. And so I know it's the player dot say transform dot position. Alright, and is there anything else? Any other parameters? I can't think of any just off the top of my head. Okay, so now I need to actually use them. So set initial references here and start, and update is check if player in range. Okay, so I've got my functions all set up. My script looks like it's working. I need to attach it and set the detection layer. So let's go and do that. Ooh, I forgot to do something. That's a very good warning message. I put in there detection radius and never set what that was. So let me do that. I'll say 50 units. That was helpful. Alright, coming back here, I'll now go ahead and put in here enemy chase, and I'll set the layer to player. Alright. And actually, for example, I'll set it to 10 at the moment, just so that you can see that in fact the enemy can lose the player and then it won't do anything. So if I hit play now, let's see what happens. Does anything happen? Yes, it is doing something. What exactly did happen? Okay. So long as I stay within its range, the enemy continues to find me. That's right. Now if I run away more than 10 meters, it'll go to the last known position, and there it stops. It doesn't know where the player is anymore, and it stops pursuing. But if I get closer, there you go, it knows where the player is, and chases the player. Now if I fire away, bang, the AI is finished, and they're done for, and well, they don't pursue the player anymore. So that actually worked nice, and now if I set it to something more sensible like 50, the AI will be able to find the player very easily, and it'll continue to chase after the player whenever I'm further away than the stopping distance and within the detection range of 50 units. So it'll keep chasing after the player. As you can see that happening right now, it's quite slow. So that's pretty good. I'm quite happy with that. And as you can see, that worked. Did you see how the AI smashed through the wall? That's why I attached the collider. Just makes it a little bit more interesting. Alright, so that's successfully working. I'm quite happy with that. Let me blow that AI up, the evil cube. And okay, we're done here. I think the next thing I need to show you is how to spawn a bunch of them at the same time to make things a bit more interesting. Alright, thanks for watching, and see you in the next video.